I'm Anil Kumar. In this video, we will see how acceleration due to gravity helps us to solve questions wherever the vertical movement is involved. The question here is, a stone is tossed upwards at 5 meters per second from the roof of a building 80 meter high. When will it hit the ground? That's the question for you. You can pause the video, answer the question, and then look into my suggestions. Now we'll solve this from very basic principles. Let us say this is the building for us. That's the ground. So what we are saying here is that a stone is tossed upwards. That means from here the stone will go kind of like this and then drop down, right? So basically it's a vertical movement of the stone which we are going to model with the help of an equation. Correct? That's the whole idea. So let's look into initial conditions which will help us to solve such questions, right? My approach here is kind of a general approach which you can apply in solving any such question, right? So let us assume here, well, we are given the value, but anyway, initial condition is that at starting, we'll call Ti, we'll keep that time as 0, the starting time. At this instance of time, we'll have the height of this building. Height initial is actually the height of the building. We are given this height to be 80 meters, right? So we'll put 80 meters here. Then we have initial velocity. Velocity in this case is given 5 meters per second, and it is going upwards as shown here in this diagram. Now what do we need to find is when will it hit the ground. So those things are final things. So when will it hit the ground? T final is something which we want to find. But at that instance of time, height will be 0, and that should help us to solve the question, right? Now the idea is from where to begin, right? All these things are known to us, but from where to begin. Now that's very important, and that is where at times we get stuck. So here, as you know, it is acceleration due to gravity. That is the gravity. Now acceleration due to gravity is what keeps things moving in this direction. So force of attraction pulls everything down, and what we know about them is that if you're working in MKS system, acceleration due to gravity is minus 9.8. It is minus 9.8 units of meters per second square, right? Now that is a force, and as you can see, this is constant near the surface of the earth. As you go far ahead, this force may decrease, right? So if you go in the space above, it is very less, right? So constant near the surface of the earth. So this is the critical place from where, whenever there is a problem of height, distance, time, you have to use this figure. If you're working in FPS systems, then A is equals to, well, I just write 32 feet per second square, right? Now that is a convention. There is nothing negative about it. I mean, it's always positive. But what we are saying is, because the stone is being, velocity is in this direction, that is my initial velocity, and this acceleration is the force which is pulling it down, and they are in the opposite direction. That's the reason why I've taken this as negative, right? Otherwise, it's just an absolute positive value. I hope that point is very clear. Now the concept here is that acceleration is rate of change of velocity. So we know that acceleration is equals to rate of change of velocity, and therefore I could now write this equation as that rate of change of velocity is minus 9.8. Does it make sense to you? As soon as we do that, we get something here which is like a differential which we had been doing, and this is called differential equation, right? So that's kind of introduction to differential equations, and now we will see such differential equations, how can be solved. Since we have not learned many techniques, what we can do is we can at least use our knowledge and do the reverse operations. We call that as antiderivatives. So we have to find this value of v. We say, well, v is equals to something whose derivative is that, a constant. So we know kind of it should be minus 9.8 times the independent variable plus some constant. Perfect. If you take derivative of this, you get minus 9.8. Derivative of k is 0. So you get back your previous equation. That means this is absolutely correct. Now at this stage, to find the value of k, you have to use the initial conditions. And we say, well, Ti is 0. At that time, Vi is 5 meters per second. So we can substitute those values right here. So we say 5 equals to minus 9.8 times 0 plus k, and that gives k as equals to 5. Perfect, because this is 0 factor, right? So we can now write our equation for velocity as minus 9.8 t and the velocity, initial velocity, which is plus 5. Right? So in general, this equation will kind of look like this. Velocity is equals to minus 9.8 t plus initial velocity, right? That is the general equation for the same. Now we know what is velocity. Velocity is rate of change of displacement. In this case, it is the height which changes. So we'll call this as rate of change of height. That is the displacement, right? And that should be equal to this expression of velocity, which is minus 9.8 t plus 5. Again, we landed up with an equation which has a derivative on one side. This is called differential equation, and to solve this, we have to find antiderivative. Perfect. Now this is one of my first videos, and therefore I'm going very slow trying to explain you all these steps. Some of you who are getting bored, they can actually skip to the end and see the whole solution. Now once we take antiderivative, the idea is that height should be such that its derivative is what is written there. So now we have t, so it is minus 9.8. Reverse operation we are doing, we can write this as t squared over 2. That one is constant. We'll write this with 5t and some other constant. Now at this stage, if you find the derivative of this, 2 times minus 9.8t over 2, 2 and 2 cancel, and we get exactly where we started from. Derivative of this is 5, perfect. Derivative of this is 0, that is correct. So this is how we did. We find height in these terms, and to find the constant, what should we do? Again, initial conditions. So Ti equals to 0. At that time, height is height of the cliff, which in our case is 80 meters. Correct. So we'll substitute this value 80 meters here and find the equation. So 80 equals to minus, this is 4.9, right? T square plus 5 times 0. T square is 0 for us. Okay. Plus c, and that gives you c as equals to, these two terms are 0, 80. So what you get here is the equation height is equals to minus 4.9 t square plus the initial velocity times t plus the initial height, which is 80, right? So let me rewrite this equation right there. So height at an instance of time is equals to minus 4.9 t square plus initial velocity times time plus initial height. So that becomes a very general equation. So we just derived two general equations which you could use directly and solve such questions, right? There's no need to do always this kind of calculation. Okay. Now getting back to the question, we want to find when will it hit the ground. at that time height is 0. So we have to solve for t when h equals to 0. That means hit the ground. Perfect. So that is what you need to do. This is a quadratic equation, so we can always solve this using the quadratic formula. You can sometimes factor, but let me use quadratic formula here. Decimals are involved, so just use quadratic formula. Okay, so t can now be written as equals to minus b, which is minus 5 plus minus square root of 5 square minus 4ac, 4 times minus 4.9, c is 80 square root, divided by 2 times minus 4.9, all this. Now you can actually pause the video, calculate this answer, and then write it down. T has to be positive, so you have to take the root which is positive. That's the whole idea, right? So what we get here is, let me calculate the square root part first. It is 5 square, minus is plus, so we'll just do plus 4 times 4.9 times 80. And that is equals to, let's take a decimal value, 39.9. So you could do this as minus 5 plus minus, okay, 39.9 divided by minus 9.8, correct? That is what it is. Since these are negative numbers, we'll actually use the negative number here both. That means negative becomes positive, right? So basically you could now I'll add 5 to this and divide by 9.8. Is that okay? So I'll add 5 to this equals to divide by 9.8, approximately 10, and we get some value which is 4.58. So we get 4.58 as our answer, correct? So that is the time it will take to hit the ground. If you take the positive value, you'll get negative t, right? So which is not the case for us, not a valid answer. So that becomes the solution, right? So when will it hit the ground? You can write the answer as after, let's say, 4.6 seconds, right? So that becomes the answer for this question. Now it's important to go through this once again. Normally when this question is there, starting point is very important to understand. It is acceleration due to gravity. Select the right value depending on the units, and then you can move forward. Those of you who remember the formula can just write down the formula, get the answer. But if you are doing this question as a part of differential equations, it is important to show all these steps to get full marks. I'm Anil Kumar, and I hope that helps. Thanks for watching and having patience with me. You can always share and subscribe my videos, and if you like, you can always put a like. Feel free to comment and post questions. Thank you, and all the best.